In today's video, we're going to talk about NASA's exciting Europa Clipper mission. This mission aims to explore Jupiter's icy moon, Europa, and uncover its secrets. Europa Clipper will investigate the icy surface and the potential subsurface ocean of Europa, searching for conditions that might support life. Europa has long intrigued scientists with its mysterious nature. The Europa Clipper mission is designed to solve the mysteries of this fascinating world and represents a significant step in our journey of space exploration. Let's begin our journey into the fascinating world of the Europa Clipper. Europa is one of Jupiter's 4 largest moons and was discovered by Galileo Galilei in 1610. Unlike other moons, Europa is covered in ice and is believed to have a subsurface ocean, making it a unique and intriguing target for scientists. Europa is about 3,100 kilometers in diameter, slightly smaller than Earth's moon. Its surface is relatively young, with very few craters, indicating that it is continuously being resurfaced. The surface is marked with cracks and lines, which could be the result of movements in the ice shell over the underlying ocean. Previous missions, especially the Galileo spacecraft, have provided substantial information about Europa. Galileo's data suggested that a vast liquid ocean might exist beneath Europa's icy crust, sandwiched between the icy shell and a rocky core. This makes Europa particularly interesting for astrobiology, because water is a key ingredient for life. The Europa Clipper mission aims to investigate these mysteries more deeply. It is designed to confirm the existence of the subsurface ocean and analyze its chemical composition. The mission will explore the ice shell and the underlying ocean's potential for supporting life. So, what makes Europa so special? Scientists believe that Europa's icy surface conceals a massive ocean kept liquid by the heat from tidal forces exerted by Jupiter's gravity. This ocean could contain more water than all of Earth's oceans combined, and if so, it might offer an environment where life could exist. Now let's dive into the objectives and goals of the Europa Clipper mission. This mission is designed by NASA to explore Jupiter's icy moon, Europa, and unlock its secrets. What are the primary goals of this mission? First and foremost, the primary objective of Europa Clipper is to confirm the existence of the subsurface ocean beneath Europa's icy crust. Previous missions have suggested the presence of this vast liquid ocean, but Europa Clipper aims to provide definitive proof of its existence. The second main goal is to study the chemical composition of this ocean and assess its potential for harboring life. The data from Europa's surface indicate various chemical compounds in the ice. Europa Clipper will investigate whether these compounds are also present in the subsurface ocean, which could significantly enhance Europa's potential to support life. Another key objective is to understand the structure and dynamics of Europa's ice shell. The spacecraft will use its instruments to map the surface features, such as cracks and ridges, providing insights into the geological processes at work. This data will help scientists understand Europa's geological history and current activity. Europa Clipper also aims to study Europa's magnetic field and plasma environment. These studies will offer more information about the moon's internal structure and the depth of its ocean. Additionally, they will help us understand how Europa interacts with Jupiter's powerful magnetic field. Finally, the mission will pave the way for future exploration missions, including potential landers. By identifying safe landing sites and evaluating the surface conditions, Europa Clipper will provide essential information for future missions that might land on Europa's surface. The objectives of Europa Clipper are not only to unveil Europa's mysteries, but also to gather crucial data for future exploration of other icy moons and ocean worlds in our solar system. This mission is a significant step in our quest to find life beyond Earth. NASA has spent years meticulously preparing for the Europa Clipper mission, ensuring that every detail is accounted for to guarantee the mission's success. Let's delve into the preparations and the steps NASA has taken. First, the planning process for Europa Clipper began in earnest in 2013, when NASA announced the mission concept. Since then, Teams of engineers and scientists have worked diligently on the spacecraft's design and scientific objectives. After defining the mission's primary goals, a suitable spacecraft design was developed, involving collaboration between engineers and scientists to produce the best solutions. Building and testing the spacecraft was another crucial phase of the preparations. NASA designed Europa Clipper to withstand the harshest conditions of space. The spacecraft underwent various tests to ensure the functionality and durability of each component. One of the primary concerns during testing was how the spacecraft would cope with Jupiter's intense radiation environment. Selecting and integrating scientific instruments was another critical step. Europa Clipper is equipped with a suite of advanced instruments to study Europa's surface and subsurface ocean. These include high-resolution cameras, radar systems, spectrometers, and magnetometers, each designed to fulfill specific scientific goals and integrated into the spacecraft. International collaboration played a significant role in the preparation process. The Europa Clipper mission is bolstered by partnerships with the European Space Agency, ESA, and other international collaborators. These partnerships have contributed significantly to the development of scientific instruments and mission planning. The launch preparations were also conducted with great care. NASA selected SpaceX's Falcon Heavy rocket to launch Europa Clipper. This powerful rocket is ideal for safely sending the spacecraft on its long journey to Jupiter. The launch window was carefully planned to determine the most efficient route and timing to reach Jupiter. Finally, NASA's mission control team will continuously monitor and manage Europa Clipper throughout its flight. This team will oversee every step of the spacecraft's journey, ready to address any issues that arise and guide the collection of scientific data. These meticulous preparations are vital to the mission's success, ensuring that Europa Clipper can overcome the challenges it will face and achieve its scientific goals. Now let's take a closer look at the technical features and instruments of the Europa Clipper spacecraft. This spacecraft is equipped with cutting-edge technology to explore the mysteries beneath Europa's icy surface. Europa Clipper's structure is built to withstand the harsh conditions of space. The main body houses various scientific instruments and electronic components, protected by robust construction. Additionally, the spacecraft is equipped with radiation shields to guard against Jupiter's intense radiation. The spacecraft uses large solar panels to meet its energy needs. These panels are designed to generate sufficient energy even in Jupiter's orbit, ensuring the spacecraft's operations. The solar panels are highly efficient and capable of sustaining the mission's power requirements. Europa Clipper maintains constant communication with Earth through an advanced communication system. A high-gain antenna transmits the collected data back to Earth. This system ensures that the data is sent quickly and reliably. Europa Clipper carries a suite of advanced scientific instruments to conduct detailed studies of Europa. Europa Imaging System, EIS. High-resolution cameras that will capture detailed images of Europa's surface to map its features. Radar for Europa assessment and sounding. Ocean to near surface. Reason. A radar system that will probe the ice layers to determine their thickness and the depth of the subsurface ocean. Europa Thermal Emission Imaging System, ETHEMIS. An instrument that will map the surface's heat distribution, identifying geologically active areas. Mapping Imaging Spectrometer for Europa, MISE. A spectrometer that will analyze the chemical composition of Europa's surface, mapping the distribution of various compounds. Plasma Instrument for Magnetic Sounding, PIMS. A magnetometer that will study Europa's magnetic field and plasma environment to gain insights into its internal structure. Mass Spectrometer for Planetary Exploration, MASSPEX. An instrument that will analyze Europa's atmosphere and surface gases to determine their chemical composition. Europa Clipper will perform close flybys of Europa's surface, collecting data from various altitudes. These flybys are designed to capture high-resolution images and gather detailed information about the ice and the subsurface ocean. Each flyby will utilize different scientific instruments to obtain comprehensive data. The spacecraft is equipped with an advanced thermal control system to regulate its internal temperature. This system ensures that the electronic components operate within their optimal temperature range, protecting them from extreme temperature variations in space. Europa Clipper is equipped with sophisticated navigation and guidance systems to maneuver safely within Jupiter's and Europa's strong gravitational fields. These systems ensure the spacecraft maintains the correct orbit and achieves its scientific objectives. These features make Europa Clipper a highly capable spacecraft for exploring Europa's secrets. Let's delve into the launch plans and the journey of Europa Clipper to Jupiter. This phase is one of the most thrilling parts of the mission and involves several crucial steps to ensure the spacecraft reaches Europa. Europa Clipper will be launched aboard SpaceX's powerful Falcon Heavy rocket. Falcon Heavy is one of the most powerful rockets available today, capable of carrying Europa Clipper on its long journey to Jupiter. The launch will take place from Cape Canaveral Space Force Station. NASA has meticulously calculated the launch window to determine the optimal time and route to reach Jupiter. The journey of Europa Clipper to Jupiter will take approximately 3 to 6 years. The duration depends on the spacecraft's orbital maneuvers and energy efficiency. The spacecraft will use gravity assists from Earth and Mars to gain speed and conserve energy. These maneuvers will help the spacecraft stay on the correct path and reach Jupiter. Upon arrival at Jupiter, Europa Clipper will enter Jupiter's strong gravitational field and perform a series of orbital maneuvers to settle into an orbit around the giant planet. These maneuvers will position the spacecraft for close flybys of Europa. These maneuvers have been carefully planned to maximize the scientific return of the mission. Once in orbit, Europa Clipper will conduct its initial flybys of Europa. During these flybys, the spacecraft will pass very close to Europa's surface, capturing high-resolution images and data. Instruments like the radar and spectrometers will study the ice layers and the chemical composition of the surface and subsurface. Each flyby will enable Europa Clipper to gather detailed data using its scientific instruments. This data will be transmitted back to Earth for analysis by NASA's scientific team. The initial flybys will provide significant insights into Europa's surface and the subsurface ocean. Europa Clipper's mission will span several years, involving multiple flybys of Europa's various regions. Over this period, the spacecraft will collect a comprehensive dataset, offering deep insights into Europa's geology, the chemistry of its ocean, and potential biological activity. The powerful magnetic field and radiation belts of Jupiter pose significant challenges for Europa Clipper. NASA has equipped the spacecraft with radiation shields to protect its electronics and has developed precise maneuvers to navigate Jupiter's gravity safely. The mission control team will continuously monitor the spacecraft's position and functionality, ready to address any issues. Europa Clipper's launch and journey have been meticulously planned to ensure a successful mission to explore Europa's secrets. Now let's focus on the scientific research that Europa Clipper will conduct once it reaches Europa, and the exciting discoveries we anticipate from this mission. This phase represents the core of the mission, where the spacecraft will gather critical data about Europa. Europa Clipper will create detailed maps of Europa's surface using high-resolution cameras and radar systems. These instruments will identify cracks, lines, and other geological features, providing a comprehensive view of the Moon's surface. These maps will reveal Europa's geological history and active processes. The radar for Europa assessment and sounding, ocean to near surface, reason, will probe the ice layers to measure their thickness and the depth of the subsurface ocean. It will also detect the structures and potential water pockets beneath the ice, providing a better understanding of Europa's subsurface environment. Analyzing the chemical composition of Europa's surface is a primary objective. The Mapping Imaging Spectrometer for Europa, MIS, will detect various chemical compounds on the surface and map their distribution. This analysis will help us understand the composition of the ice and other materials. The Europa Thermal Emission Imaging System, ETHEMIS, will map the heat distribution across Europa's surface, identifying geologically active areas. These thermal maps will highlight hotspots that may indicate subsurface activity. The Plasma Instrument for Magnetic Sounding, PIMs, will study Europa's magnetic field and plasma environment. These studies will provide insights into the Moon's internal structure and the depth of its ocean. Additionally, they will help us understand how Europa interacts with Jupiter's magnetic field. The Mass Spectrometer for Planetary Exploration, MASSPEX, will analyze Europa's thin atmosphere and surface gases. This analysis will reveal the chemical composition of the subsurface ocean and potential biological activity. One of the most exciting goals of Europa Clipper is to explore the subsurface ocean beneath Europa's icy crust. Confirming the existence and analyzing the chemical composition of this ocean could greatly enhance our understanding of Europa's potential to support life. If organic compounds or other signs of life are found in the ocean, it would be a groundbreaking discovery in astrobiology. The scientific investigations by Europa Clipper will provide comprehensive and detailed information about Europa's surface and subsurface ocean. These findings will shed light on Europa's geological activity, chemical composition, and potential biological processes. They will also enhance our understanding of Europa's ability to harbor life and lay the groundwork for future exploration missions. The discoveries from Europa Clipper will not only advance our knowledge of Europa, but also provide valuable insights into other icy moons and ocean worlds in our solar system. These insights will significantly impact our search for life in space and expand our horizons in space exploration. The Europa Clipper mission promises groundbreaking discoveries, but it also faces numerous challenges and risks. Let's explore these challenges and the measures NASA has taken to mitigate them. Jupiter's magnetic field is one of the strongest in the solar system, posing a significant challenge for Europa Clipper due to the intense radiation it generates. This radiation can damage the spacecraft's electronics. NASA has equipped Europa Clipper with special radiation shields to protect it from this harsh environment. The spacecraft's critical components are encased in radiation-resistant materials to ensure their safety. Europa Clipper's journey to Jupiter will take several years, involving numerous orbital maneuvers to stay on the correct path and conserve energy. These maneuvers require precision because even a small error could cause significant deviations. NASA's Mission Control Team will continuously monitor the spacecraft's position and speed, ready to make adjustments as needed. Europa Clipper will perform close flybys of Europa's surface to collect high-resolution data. These flybys require great precision because a wrong maneuver could result in a collision with the surface. NASA has developed detailed navigation plans and enhanced the spacecraft's maneuvering capabilities to ensure these flybys are conducted safely. Europa Clipper will gather vast amounts of data from Europa's surface and subsurface ocean. Transmitting this data back to Earth from Jupiter's distance is challenging. High-gain antennas and powerful communication systems will ensure that the data is sent quickly and reliably. However, these systems need to function continuously and be well maintained. Temperature fluctuations in space can be extreme. Europa Clipper's thermal control system is designed to regulate its internal temperature, ensuring that electronic components operate within their optimal range. This system protects the spacecraft's exterior from extreme temperature changes and prevents overheating or freezing of internal components. Europa Clipper's mission will last several years, requiring all systems to function smoothly and undergo regular maintenance. With limited spare parts and maintenance supplies, NASA's Mission Control Team must carefully monitor every situation and make the best decisions to ensure the spacecraft's longevity. As with any space mission, technical failures are a risk. Failures in electronic systems, scientific instruments, or communication systems could jeopardize the mission's success. NASA has prepared backup systems and contingency plans to address such failures if they occur. These challenges and risks highlight the complexity and importance of the Europa Clipper mission. NASA's meticulous preparations and precautions ensure that these challenges can be overcome, paving the way for significant discoveries. The Europa Clipper mission is not only about uncovering Europa's secrets, but also about laying the groundwork for future space exploration. The success of this mission will lead to new discoveries and enable more advanced missions. Let's explore what we can expect following Europa Clipper's achievements. The data gathered by Europa Clipper will provide crucial information for a future landing mission. NASA plans to send a lander to Europa to collect samples from the icy surface. The Europa lander mission will directly analyze the surface's chemical composition and potential biological markers, offering a deeper understanding of Europa's habitability. The successes of Europa Clipper will serve as a model for exploring other icy moons in our solar system. Moons like Saturn's Enceladus and Neptune's Triton are also believed to harbor subsurface oceans, making them prime targets for similar exploration missions. These moons might also hold clues to extraterrestrial life. The findings from Europa Clipper will also guide the exploration of ocean worlds beyond our solar system. In exoplanet research, the presence of subsurface oceans and their potential to support life are major points of interest. The data from Europa will provide valuable insights into how to study and analyze such worlds. Europa Clipper will significantly advance the field of astrobiology. The subsurface ocean beneath Europa's icy crust could potentially harbor life, given that it may contain more water than all of Earth's oceans combined. This mission will be a milestone in our quest to find life beyond Earth and will guide future astrobiological studies. The success of Europa Clipper will lead to advancements in space technology and engineering. The technologies developed for this mission, including radiation shields, communication systems, and scientific instruments, will be refined for use in future exploration missions. These technological innovations will benefit other exploratory endeavors. Europa Clipper will set an example for international collaborations in space exploration. NASA's partnerships with the European Space Agency, ESA, and other international entities will pave the way for more joint projects. Such collaborations will make space exploration a global effort and enhance the diversity of scientific research. The data collected by Europa Clipper will provide profound insights into Europa's geology, chemistry, and potential biology. This information will help scientists learn more about Europa's past and present, leading to significant discoveries in planetary science. The potential discoveries and future missions inspired by Europa Clipper mark the beginning of a new era in space exploration. This mission will not only unlock Europa's mysteries, but also open new frontiers for humanity's journey into space. The Europa Clipper mission is one of NASA's most exciting and ambitious space missions. Designed to explore Jupiter's icy moon Europa and unlock its secrets, this mission represents a significant step in our search for life beyond Earth. Europa Clipper aims to confirm the existence of the subsurface ocean beneath Europa's icy crust, analyze its chemical composition, and assess its potential to support life. The spacecraft's advanced scientific instruments will map the surface and subsurface structures, study the chemical compositions, and investigate the magnetic field. The success of this mission will provide vital data not only about Europa, but also about other icy moons and ocean worlds in our solar system. Europa Clipper will lay the foundation for future exploration missions and significantly advance our understanding of the potential for life in space. The challenges and risks associated with Europa Clipper underscore the mission's complexity and importance. However, with NASA's meticulous preparations and the safeguards in place, these challenges can be overcome, leading to groundbreaking discoveries. In conclusion, the Europa Clipper mission heralds a new era in scientific discovery and space exploration. We are thrilled to share this journey with you and invite you to join us in exploring the wonders of the Europa Clipper. Thank you for watching. If you enjoyed this video, please hit the like button and subscribe to our channel. Also, feel free to share your thoughts in the comment section below. See you in our next video. Goodbye.